Critical thinking scenarios can be an effective strategy during multiple stages of the critical and creative thinking process. In this module, we'll focus on a strategy that's especially powerful in enhancing students' abilities to gather and assess relevant information, synthesize and generate ideas, consider alternatives, and reach reasoned conclusions. I'll also share how this strategy can be transferable to almost any discipline and class context. In addition, using this strategy with incrementally more complex scenarios is excellent preparation for asking students to evaluate primary literature or other works of experts in your discipline.
One place that many of us likely want to encourage growth in our students is in the area of reaching reasoned conclusions. Our students might approach this stage under the assumption that there is a singular answer that they are trying to find, rather than there being varying degrees of certainty and support for the conclusions they're drawing. Critical questions that unpack and challenge conclusions might include: have I accurately represented the conclusions and are they supported by relevant evidence? Have I appropriately connected the problem to the conclusion? Am I dealing with the depth and complexities of the conclusion? Am I missing anything? And have I adapted my thinking and conclusions based on evidence that I gathered along the way? Specific skills that students will develop through this activity, particularly if they have several opportunities to practice throughout the semester, include providing alternative interpretations for information or observations that have several possible interpretations, and identifying additional information or evidence needed to evaluate the alternative interpretations. I suggest that when you first introduce this kind of activity in your course, you begin with topics that are unlikely to cause emotional reactions or challenge individuals' assumptions and long-held beliefs. You can work your way up to more controversial issues later in the semester once trust is built if your class calls for it. Here's an exaggerated sample scenario that can exemplify the way that conclusions can be misinterpreted. These types of exaggerated scenarios are particularly good for beginning students and as a primary introduction to reaching reasoned conclusions. The example is as follows. A scientist working in a government agency believes that an ingredient commonly used in bread causes criminal behavior. To support the hypothesis, the scientist notes the following evidence. 99% of criminals consumed bread prior to the criminal activity, and that crime rates are extremely low in areas where bread is not consumed. So the questions we need to unpack are as follows. 1. Do the data strongly support the hypothesis? 2. Are there other explanations for the data besides the scientist's hypothesis? If so, describe. And what kinds of additional information or evidence would support or oppose the scientist's hypothesis? Some of you may be familiar with this graph already, and if not, you may be familiar with the article it came from. It is from an article in a prestigious medical journal, The Lancet, and the article's lead author is Andrew Wakefield. The claims the paper made have since been debunked, and the paper was rescinded due to ethical violations and fraud, yet the impacts from the conclusions and media coverage of this so-called research is still affecting us today. We can use this graph to ask and answer the questions: what does the author of the graph want you to infer? Give an alternative explanation for the data shown in the graph. Suggest further data that you could gather to investigate the alternatives above. In this scenario, we can also use the graph to emphasize the difference between correlational and causal relationships, as well as to consider what information might be missing in a visualization of information. This final example requires a deeper and more complex understanding of a topic, data, and connections between evidence and conclusions. In this case, I selected a controversial paper that had some subtle flaws. I succinctly described for students the methodology used, the results obtained, and the conclusions drawn in the article. The topic of the paper may not resonate with you, but I'm sharing it as an example to illustrate how the critical thinking scenarios can be further scaffolded into your course to prepare students for evaluating primary literature independently. The 2014 publication by Liu et al. Entitled Sublethal Exposure to Neonicotinoids Impaired Honeybees' Winterization Before Proceeding to Colony Collapse Disorder has received considerable media attention. In the study, the researchers set up an experiment with 18 bee colonies. All 18 colonies are fed a constant supply of either sucrose or high fructose corn syrup over a period of 13 weeks from July 2nd to September 17th. In 12 of the colonies, neonicotinoid pesticides were added to the syrup in a sublethal dose of 0.74 nanograms per bee per day. Bees were permitted to overwinter as normal. The researchers observed no difference in the treated versus non-treated hives during the summer and fall months. However, in April, 6 of the 12 neonic treated colonies were dead, and 1 out of the 6 non-treated colonies were dead. Furthermore, in the neonic treated hives that had not successfully overwintered, few dead bees were found in the hive, as occurs in colony collapse disorder, whereas many dead bees were present in the one control hive that did not successfully overwinter. The authors state that the data strongly support the idea that neonicotinoid poisoning is the primary cause of colony collapse disorder. Though this may be a more complex example, the students will respond to, in essence, the same 3 questions as the simplified examples. How strongly do the data support the conclusion that neonicotinoid poisoning is the cause of the widespread problem of colony collapse? Describe any problems you see with the experimental design or the conclusion reached in the paper. And what further information would you need to assess the veracity of the conclusion, either known information or further experimentation that could be pursued? If you are teaching a research-based or experimental course in any discipline, you can use examples of experiments to help students develop these skills. For example, students design an experiment but neglect an important control. They must describe all of the possible interpretations of the data and figure out how they should redesign the experiment to rule out some of the possibilities. You can also utilize current headlines or claims in the media relevant to your course content, collected either by the instructor or students. Examples confounding correlation and causation include girls who play soccer have more success in STEM fields. Frequent reliance on social services yields shorter lifespan. Eating fast food leads to depression. And here's an example where quantitative reasoning is needed to identify missing information. 77% of students infected with influenza in the 2021 University of Michigan influenza outbreak were unvaccinated. You can create critical thinking scenarios with any overstated claims in primary literature. Advanced students can read an entire paper, or less advanced students can be provided with a simplified summary of data and conclusions drawn. Again, I do suggest introducing this activity with topics that are less likely to challenge existing assumptions or strongly held beliefs, as students may consciously or unconsciously be closed to this kind of thinking exercise. Introduce topics that may challenge assumptions once students are comfortable with the process.
Is there a common misperception you see among your students or related to your discipline? Have you ever read or watched a report in the lay media that seems exaggerated based on the existing evidence? What about claims made by politicians or companies that might gain by a commonly held misperception? Or how about examples in primary literature in your discipline where alternate explanations were not thoroughly explored? These are all opportunities for your students, and now that you know the formula, you'll notice these learning opportunities everywhere.